Hi, this is Mark Kemper with EMS, and in this video we're going to demonstrate the new Creaform GoScan 3D scanner. Now the first thing you'll probably notice about the GoScan is just how small and portable it is. It literally weighs about 2 pounds, 2.1 pounds I believe to be exact. It has two cameras on it right here and a light source. Now Creaform has been known for quite some time for making handheld scanners, but traditionally they've always been laser-based scanners. So the light source was a laser-based stripe, or actually two stripes in an X pattern that would scan the part. This is a structured light or white light LED light source. So instead of a laser, it's a projector in here that projects out a structured light pattern onto the part. Now the advantage of that is we can project out a pattern of about 15 inches square and scan extremely fast as we go along. So you're capturing a very large area very quickly. And again, it's very portable and fits a lot of applications we're going to talk about here today. But other than what I've pointed out, there's also some LEDs here. Those are for targets, which I'll explain in a few minutes, but those light up reflective targets. There's basically the trigger right here. You just pull the switch to scan. And there's a couple readout lights up here on the top that tell us if we're too close or too far away. And that's really it. It plugs into a single USB cable that you plug into any computer, and you're ready to start scanning. Now with the scanner comes a travel case, and again, because the scanner is so small, it's a pretty small case. You can carry this onto an airplane, put it in the overhead, and away you go. So you can literally go anywhere with the scanner. And the scanner is very easy to use, so somebody that doesn't do scanning on a regular basis should be able to pick this thing up and do scanning with it. Now let's start with this part back here, and what this is basically a vacuum formed piece of plastic. And you can see it's got some detail on it, but not a lot. What's different about this scanner than the traditional HandyScan scanners and a lot of scanners is they require targets as you move around. This one doesn't. What it does is as it scans, it's doing a big enough area, it's really looking at feature recognition as it moves around. So as long as I have enough descript data as I move around, the software is going to auto-align those scans as you go along. Okay? Now, if I were to try to scan this flat table with nothing on it, it really wouldn't work because there's nothing unique about it. Or think about going down the side of a car. It would have trouble because there's just not enough data there to define it to align to. But let's go ahead and scan this and we'll talk more about it. So all I do is I hold the scanner in my hand. I can hold the part in my hand if I like, or I can set it down. I hold it about 15 inches away, and I pull the trigger. Let me move so you can see the screen there. Okay, so you can just see how fast it is. Okay, now it's line of sight like pretty much every scanner. So I've got to at least either turn the part or turn the scanner so I can see the geometry. And I'm going to go ahead and let it just scan my hand so you can see that it scans human tissue very well. So it's very good to use in any kind of medical applications, whether it be prosthetics and so forth. Okay. But basically I'm done. Okay, so I scanned that part extremely fast, and we'll come over here to the software. Now the software that comes with it is the VX Element software, which is the same software that runs all the Creaform scanners. It's a pretty powerful scanning acquisition software, but basically there you have it. Okay, so you can see we've scanned that. Looking there, we've scanned 90,000, or we have displayed 90,000 triangles on the screen. So the way this works, like the HandyScan scanners and the Metroscan and the others, is it scans it, and underlying is the point cloud data, or basically the individual scan points, that when you hit stop scan, it processes that into a polygon mesh. So what I'm actually seeing now on the screen is a triangulated mesh of 90,000 triangles. Now the default setting is 2 millimeters, okay, and that's what I see here. But if I want higher resolution, I could set that to 1 millimeter all the way down with this scanner down to 0.5 millimeters, and then reprocess or retriangulate it. The reason I would do that is the tighter or the smaller the triangles, the more detail I will get. So that's totally up to the user as far as resolution, what you're going to get. As far as accuracy, it's within about 0.1 millimeters, so it's pretty good accuracy. For the applications it's really going to work well for, that accuracy should be just fine. So again, you can see how quickly I scanned that. Now let's go ahead and reset the project, so we'll just go ahead and delete that. We're going to scan again. I'm going to do this mannequin head here. So this one's a little more complicated in shape. Again, I just simply hold it about 15 inches away, and there's a meter on the screen and also on the scanner that tells me if I'm too close or too far away. Now, because we're using feature recognition, okay, I'm going to stop scanning here for a minute, and on the screen I can see kind of an aqua area, which is basically where the last scan was taking. I can't scan here and then come over here and try to scan. You can see it's trying to line the data up, but it doesn't know where I am. So without using, in this case we have no targets, I have to start and stop kind of in the same spot. So I need to come back to that same spot and then move around, because again, it's using the geometry itself to align the data as it moves along. Okay? So it's projecting this pattern out, it's looking at the distortion of the pattern like many scanners do, and of course it's line of sight, as I mentioned. Okay? And you can see I can move around, I can get under the chin, behind the ears. Now in this case I can turn the part as long as I pretty much start and stop in the same spot and continue to move around. So again, you can see just how quickly you can scan with this scanner. Okay? So let me go ahead and hit stop again. And again, it'll process it. Okay, now we didn't scan the entire thing, but most of it. You can see how quickly we scanned it. We can reprocess that down to a lower, smaller triangles if we want. The last thing I'm going to do, so I'm going to go ahead and stop that scan. And I'm going to reset the project, and we're going to do something with targets. Okay, so what we're going to do here is I've got a femur bone, and we've got it on a little fixture. And what I've done is I've put some targets around the part. Now the targets don't have to be on the part, they just need to be in the foreground or the background. And I've got some small triangles with targets on it. And the reason I feel I need targets on this is as I'm scanning this bone, especially here in the middle, it's kind of very nondescript. And there's probably not a lot of data to really lock it in and make sure I get a good scan. So simply by throwing a few of these triangles, and I've got just a few triangles with the targets on it and a few targets on the table, I should be able to scan it. And I don't have to do anything special. The software will recognize that there's targets in the field of view and allow us to acquire them. So the targets, the best way to think of it is like GPS. As long as it can see three targets, it'll triangulate itself in space. So think of the targets as satellites, and as the scanner is your receiver, your GPS unit. So as I start scanning, it's going to collect the data, and it's going to use a combination of both the feature recognition, but also the target locations. Okay, so as I move around, okay, and pick up the bone, and where that's going to be especially handy is I try to get down here, lean down, and really come across this femur bone and get it in the middle there. Again, you can see those targets. Now the advantage is I just stopped over here. I can start over here because again there's targets, so I can start and stop as long as I've already scanned those targets. I'm good to go. Okay, so I'll come up here over the top, maybe reach over. Okay, so in this case I'm using a combination of the feature recognition and the targets, and that's somewhat unique in a handheld structured light scanner. This one you will use both feature recognition and target recognition to scan it. So depending on what I'm doing, we'll add targets to it. And you don't necessarily need a whole bunch of targets, but probably every 4 to 8 inches, depending on what we're scanning, just so it can see at least 3 of them and keep that data aligned. Okay, so targets are handy to have in certain applications, but for many applications you don't need them. So what we'll do next is I'll go a little bit more into the software, because the new GoScan scanner has some software bundle options. One is called Go Model, and we'll go into that and kind of show you what you can do with this scan data. So at this point we're done. We would just save it out as an STL file. Again, we can retriangulate down to a smaller mesh size if we like, and then we're going to export it out, and then we'll talk about different applications to work with the scan software. But to wrap up with the scanner, it's very portable, it's very fast, it's easy to use, and for a lot of applications it's going to be a perfect fit, because it doesn't require a lot of setup, doesn't require a real expert. Basically anybody can learn to run this scanner in a few minutes. So let's go ahead now and go to the software, and we'll get into more of how that works. Okay, so here we are now in the Go model software. Now what the Go model software is the Rapidform XOS software. The only difference with the Go model version of the software is that it has been configured to only work with the GoScan scanner. So the standard Rapidform XOS product would be able to import scan data from any scanner or really any other source. The Go model version of it has all the same commands. The only difference is you can only import scan data from the GoScan scanner. Now by doing this, you can purchase the Go model software for half the price that you would normally purchase the Rapidform XOS software, but they also have some upgrade paths if you want to upgrade to XOR or get additional seats of XOS. So let's go ahead and go in here and just show some of the things that you can do in the Rapidform software. Now, we had scanned the femur bone, and really because of the way we fixtured it, there's no way to scan 360 degrees around the femur. So we actually had to set it up, scan it, save that file, flip it over, scan it again, and save that file. And that's very typical of a lot of things. You're not going to be able to scan them in one setup just because of their shape, whatever it is. So let's start here in the Go model software. And the first thing we're going to do is an alignment. So whether it's 2 sets of scan data or 20 sets of scan data, it really doesn't matter. But we have a few different options, and we're going to do what's called local based on pick point. And all I'm really doing is picking the 2 sets of scan data, and what I like to do is just kind of rotate them so they're in pretty much the same view. So you can see in the green is kind of the bottom, we'll call it, and the blue is the top. And then what I need to do is just kind of pick some common points, usually at least about 3 of them, and what that's going to do is kind of get the data close, and then we'll go ahead and execute the command, and it'll pretty much line it up. And then what we're going to do is just a global and fine, and that's just going to try to tighten it up a little bit more, looking in a smaller area. So right now there's still 2 separate sets of scan data, as you see here, but they're lined up. So the next thing I'm going to do is go ahead and merge them together, and just select them both and hit merge. So what that's going to do is now turn them into one set of scan data. And there might be, you can see a couple little holes, some rough spots. So we've got a few options here. So I'm in the mesh edit mode here, and I'll just kind of walk through some of these things. So we can smooth, we can fill holes, we can decimate, we can defeature, we can rewrap, we can remesh, a whole bunch of commands. The most common ones we use are filling holes. That's where you manually come in. You might pick a hole and fill it in. What we'll do is what's called the remesh command, because this typically will fill in holes for us and do it all automatic. So what the remesh does is really goes through the whole model, completely remeshes it, and fills in as many holes as it can. So you can see now it's filled in all those holes and it's remeshed it. Okay, so that's a pretty common command we'll use. Next step though is maybe I want to do some kind of local smoothing. So there's a smart brush that lets me do smooth and decimate and clean and so on. But basically it's like virtual sandpaper. So I can just come in and rub. There's some kind of rough spots on those bones, and I'm going to smooth them out. Because what I'm doing here is for an application where we're going to scan some bones and use these to design some plates. Some implant plates that maybe after someone breaks a bone or fractures a bone, they're going to use a plate and screw it into the bone, basically to hold the bone together. Okay, so I'm going to get rid of some of those rough areas, and I'm going to smooth it out. So I can do this locally, I can do it globally on the entire part, and again, the more I rub over an area, the smoother it gets. Okay, so that's another nice feature of the Go model software. Okay, so I'll look at it now and say, hey, that looks pretty good. Another thing I can do is what we call defeature. So sometimes there might be something, maybe on this particular bone, this area here I just don't want, or it's too large, or something like that. I could literally come in and draw around it like this and hit OK. It's essentially going to delete that area, basically that large bump, and then fill it back in with curvature-based filling and fill that area back in. Okay. Okay, so next what we're going to want to do Let's take a look at this. So what we have here is a cleaned up polygon mesh. And again, what a polygon mesh is really just a bunch of triangles. So if you zoom in by remeshing it, it's just evened them out and kind of smoothed them out. But basically it's a bunch of triangles. Now at this point we can export an STL file, and that could be used for 3D printing, rapid prototyping, CNC machining, a whole bunch of applications. And some software can work directly from this polygon mesh. But other systems, more of your solid modeling systems, they're going to require a surface or solid model. One of the other features in the Go model software is a command called AutoSurf, and we're going to use an option called feature following network. And what this is going to do is go through and calculate and basically build a patch of, we kind of call it a quilted patch of surfaces over the part. Now using the feature following network, it's going to try to minimize the amount of surfaces required to surface wrap this or auto surface it with a more intelligent set of surfaces that kind of follow the shape of the part. Okay, so as you see here, it's calculating. It takes a few minutes, but it's going to go through and divide this up and try to make basically NURB surfaces, and if it can wrap those surfaces all the way around the part, we'll end up with a basically a watertight manifold. So what I get here is kind of a preview of those patch areas like you see here, and again it looks at the geometry and tries to intelligently figure out the best way to calculate all those surfaces. And there are some settings we can set, but it's basically done. So what we end up with, if we hide the mesh, what we now have is and you can see it right here, it's a solid body. It's completely, meaning it's completely enclosed of that femur bone. So now I can come in here and I can export this instead of as an STL file. When I export it, I have options that include step, IGES, Parasolid. You can even do a direct CATIA format, A6, and some others. So now you have in this case, a solid model. Now it's made up again of a bunch of quilted surfaces, but you can bring this into a CAD system or even a lot of CAM systems and then work with it. Okay. So again, what you have here is an exact representation of the scan data. So let's turn that off and go back to the scan data. There's the scan data. And now here's our solid model. And if I turn off the edge lines, you can see it's smoothed out or without the edges. But again, it's a solid body that can be used in a lot of CAD systems. Now another feature, let's go ahead and just hide that for a minute and turn our mesh back on. Another surfacing feature available to you in the Go model software is what we call boundary fit surfaces. So, using our example of maybe designing a plate for this bone, we could just surface up certain areas of it. So let's say we want to do an area over here. So what I do is I come under the 3D mesh sketch command, and there's a lot of ways we can generate meshes, sketches off those meshes. But essentially what I'm going to do is I'm just going to draw a series of curves, and those curves will fit as I pick points. It'll actually fit those curves right onto the mesh. Okay. So basically what I'm doing is I'm just drawing a small area that I want to surface up. Okay, so you can make these curve networks anywhere you want, and the curves will actually follow the shape of the mesh. Okay, and then instead of doing an auto surface, I'm going to do what we call a boundary fit surface, and it's going to then just generate surfaces within those, in this case, splines that I generated, or what we call mesh sketches. Okay, so now I have a couple surface patches, again, that represent that mesh that we had scanned or generated from that scan, but only in this area. So if I just want to do smaller areas, again, it's still a NURB surface. When I go to export, I'm going to have those same options again of IGES, step, etc. But this time it's going to go out as a surface model because there's no thickness to it. It's just basically a skin. Okay, so basically to run through the Go model software, you've got full mesh editing capabilities, and in this demo we don't have time to go through all of them, but there's numerous commands to align scan data, mesh it, remesh it, decimate it, smooth it, fill in holes, defeature it, etc. pretty much everything you'd want to do to be able to scale it, rotate it, all those types of things, put it in a coordinate system. And then you have some surfacing options, which includes the boundary fit command and the auto surface command. So it's a pretty robust product. Now to move up, the next module up is called XOR, which gets into solid modeling and 2D and 3D sketching and some other stuff. But for a lot of applications, the Go model will work just fine. Okay, and we'll show one more thing here with the Go model software. We're going to go ahead and load in some scan data. And this was of a person we'd scanned, and you can just kind of see the data here. Let me hide the plane so you can see it scans skin very well. It'll scan some facial hair. Probably have a harder time with regular hair, as most scanners do, just because of the translucent nature of hair. But you can see the body itself. And what we did is, and I'm just going to load this to show it, is we basically trimmed the mesh down to the face area, cleaned it up a little bit, smoothed it out, and then we auto surfaced the face. So if I hide the mesh, again, we now have a nerve surface model of this person's face, which can be used for, basically whatever your application may require. So that wraps up just a quick demo of the GoScan scanner and the Go model software. And bundled together, it's a very attractive price and allows you to scan, bring it in, edit it, generate surfaces, and export it. And again, there is also an upgrade path to the XOR software to get into more solid modeling from scan data, and also the XOV software, which allows you to do full-blown 3D inspection.